when we take a look at A, we have to keep in mind that we're taking a look at the graph of a rational function, which is the quotient of two polynomial functions. Now, can I have 0 in the denominator? The answer is no. And since I cannot have 0 in the denominator, what I want to do is take my denominator, set it equal to 0, and see where that would occur. So if we do this, we find that it is at a value of x equal to negative 1/3 that would cause this denominator to become 0. So this means that my domain for A is negative infinity up to negative 1/3, with that negative 1/3 not included, so parenthesis, pick back up at negative 1/3 and proceed to infinity. Now B does not pose any threat because with B, all I have in the denominator is a 5. It'll always be 5, and this is not going to cause an issue by any means. So our domain here is actually just all real numbers. So negative infinity to infinity. But when we look at C, we know that we can't have, so no negatives under radical. So since I can't have any negatives under the radical, I take what's under the radical and I set it greater than or equal to 0. Remember, 0 is allowed. So x must be greater than or equal to negative 3. So in interval notation, we have negative 3. I can have a bracket because negative 3 is allowed. And I go to infinity because it's greater than or equal to negative 3. For D, we're working with a quadratic, but it's a polynomial function, and there are no restrictions. There's nothing that will make 2x squared plus 3x have an issue. So in this case, we have all real numbers from negative infinity to infinity.